Now in this lecture, we have combined all methods that we have performed in circular queue in previous lectures. So here we have combined all them together to see the big picture of time and space complexities of these operations that we have completed in our previous lecture. Now here, the first operation is create queue method. Now when we are creating a queue, we are just initializing the array in the memory. So this will take O1 time complexity because here we are declaring array and instantiating this array based on the size that is given in the parameter. So this will take O1 time complexity. Now here, as I mentioned, we are creating circular queue based on the array. So when we are creating a fixed size of array in the memory, it will take fixed number of contiguous cells in the memory. So that's why the space complexity for this creation will take On space complexity. So if the number of cells is n, so the space complexity will be On. Now the next method is enqueue method. So when we are enqueuing an element to the circular queue in case of array, we are inserting an element at the end of queue in this case. So we know that when we are declaring an array, we have set the top of queue. So based on the top of queue variable, we can easily identify the end of queue. So that's why here we are just updating that value in the cell. So updating a value of cell in the array takes one time complexity. So that's why inserting an element at the end of queue in case of array will take O1 time complexity. So as I mentioned, in this case we are updating a cell in the array, so this will take O1 space complexity. Now the next method is dequeue method. Now in case of dequeue method, we are removing the first element from the queue and returning it. So in this case, basically we are not deleting it. So in this case, we are updating the beginning of queue, which points to the next cell. So that's why this will take O1 time complexity, because we are not doing any loop, other time consuming operations over here. So that's why it takes O1 time complexity. Now similarly, space complexity is also O1 because here we are just changing the beginning of queue. We are not touching anything over here. Now the next method is pick method. Now in case of circular queue, pick method returns the first element from the queue without deleting and without touching that element. So accessing an element in the array takes O1 time complexity. So if we access the first element in the queue, this will take O1 time complexity. Now similarly, the space complexity is also O1 because here an additional memory is not required to perform this operation. Now when it comes to isEmpty method, as we said before, isEmpty method works based on the beginning of queue. So if the beginning of queue points to the -1, in this case we are returning true, otherwise we are returning false. So as you can see, here we are just performing the operations based on the if condition. So based on the if condition, we are returning Boolean values. So this means that it will take O1 time complexity because these operations are not time consuming operation. Now similarly, here we are not performing any space consuming operation. So this will take O1 space complexity. Now the next method is isFull method. Now as we mentioned before, isFull method is different from the linear queue. In this case, we have to have some more conditions. So based on the top of and queue, we are identifying these conditions that we have explained in our previous lecture. So here also, we are not performing any space consuming operation or any time consuming operation. So that's why space and time complexity is O1, because here we are just returning the Boolean values based on the conditions that we have in our circular queue. Now the last method is delete entire queue. Now when we are deleting entire queue, we are just setting the array that we have declared in queue class to null. So setting this array to null takes O1 time complexity, and the space complexity is also O1 because here an extra space is not required for setting an array to null. So this will take O1 space complexity. Now with this, we have come to the end of this lecture. So with this lecture, we have concluded circular queue using array. Now from the next lecture, we are going to implement a queue using linked list. So see you in the next lecture.